Question 16 is related to the reversible reactions. Reversible reaction means the reaction in which the reactant can form a product and the product can form back the reactant, we call reversible. What is the meaning of a term equilibrium? Again, it's a 2-mark definition, and whenever a term definition is like anything you have to define, better learn the standard definition. That the term equilibrium means when the rate of the forward, don't say that the amount of reactant equal to amount of product, that is wrong. When the rate of forward reaction is equal to rate of the backward reaction, so when rate of forward reaction is equal to rate of backward reaction and there is no change in the concentration, of reactant and product, but we don't say the amounts are same, we say that concentrations or amount does not change. So that state is known as the equilibrium. Then the next part, why increasing a temperature increases the rate. Rate or speed of a reaction does not depend on whether the reaction is reversible or irreversible. The rate always increases with the temperature and it is of 3 marks. So what are the points you should include when you explain the rate or the speed of a reaction? So increase in temperature will increase the kinetic energy, the number of the collision or number of successive collisions, as well as or successful collision, as well as the proportion of a molecules having energy more than activation energy. So activation energy is not changing, but the number of the particles which are having energy more than activation energy will change. Activation energy can only be changed by using a catalyst. Then state and explain the effect, if any, on increasing a temperature and position of equilibrium. They mentioned this reaction is exothermic. So when a reaction is exothermic, when we work out the positions, the reactants will have high energy and the product is having low energy. So energy of the reactant, the reactants have high energy and the product is having low energy. So when the question is what will happen when we increase the temperature? So we have both reactant and product, but when we increase the temperature, the reactant will more reactant will form or product will decompose to form more reactant. So where the equilibrium will shift towards. So state and explain the effect, if any, on increasing a temperature and position of equilibrium. So it will shift towards left hand side or backward. That is 1 mark. Then what about the second mark? The second mark is just mentioning a reason here. You can mention because the forward reaction is exothermic, so backward reaction will be endothermic. So 1 mark is for mentioning where the equilibrium will shift, and the second mark for mentioning because the forward reaction is exothermic. So whenever forward reaction is exothermic, equilibrium always shift towards the left hand side by increasing a temperature. Then state and explain the effect on decreasing or changing the pressure. Increase in pressure shift the equilibrium towards side where number of moles of gas are less, and decrease in pressure shift the equilibrium towards side where number of moles of gas are more. But when we check here the moles of a gas in a reactant side, 1 plus 1, that is 2. And when we check the moles of the product, that is also 2. So whenever the moles are same for both reactant and product, so there is no effect of changing the pressure. So here the answer, there will be no effect. And what is the reason? Because there are equal number of moles of gas for reactants and products. So pressure only effect if there is a different number of moles of gas, specifically gas. It's not about total number of moles of reactant and product. We always check the moles of gas in the reactant and product side. Copper 2 sulfate solution was electrolyzed using the apparatus. The carbon electrodes are there. So what will happen? The solution contain, because it's a copper 2, so it contains aqueous copper 2 sulfate. So it contains copper ion plus 2, sulfate ion is there, hydrogen ion will be there, and hydroxide ion. What will happen? From the negative terminal, the electrons will come out. So majority of the electrons are here. And towards the positive terminal, electrons will move. So this is a movement of electrons. And because copper ions are positive ions, the less reactive positive ion will move towards the cathode. So because copper is less reactive, so copper ions will move towards cathode. So we have to draw an arrow on the diagram to show the direction of movement of electron and label that as A. So this will be label A. This will be label A, the direction of movement of electron, and draw an arrow on the diagram to show the direction of movement of copper positive ions in, so where copper ions are attracted toward the cathode, so that is represented by letter B. So A is the movement of electron and B is the movement of copper ions. And for negative ions, sulfate, nitrate and carbonate never move. So when hydroxide ion will move there, this is always a fixed equation that it gives of oxygen and water molecules. Explain why this reaction is oxidation. Look, whenever you see electron here, so oxidation is a loss of electron. So you can write this, that is a loss of electron. And some of the students mentioned there is an increase in oxidation number. That is also correct. If you mention increase in oxidation number or it is a loss of electron, that is correct. But not in terms of oxygen, because you cannot explain this reaction in terms of oxygen. But better, whenever a question is there related to oxidation or reduction, try to write the definition in terms of electrons. Oxidation is a loss of electron and reduction is the gain of electron. Because due to loss or gain of electron, there will be a change in oxidation number. So change in oxidation number also depends on the loss or gain of electron. So the standard definition of oxidation is a loss of electron and reduction is a gain of electron. Then write ionic half equation for formation of a copper at cathode. So when copper, which is a +2 ion, attracted toward the cathode, it will gain 2 electron, which is a reduction, and turn into a copper metal. Then the electrolysis is repeated using the copper electrode rather than carbon electrode. Now what we will see, and state and explain what happened to the masses of anode and cathode during this electrolysis. So now anode is made up of, the anode is made up of copper, cathode is also made up of copper. and the electrolyte is a copper sulfate. So aqueous copper sulfate contain copper ion, sulfate ion, hydrogen ion, and hydroxide ion. So what will happen when the copper ions are attracted towards the cathode? Due to this attraction, the copper will stick towards the cathode. So what will happen to the mass of the cathode? The mass of cathode will increase. Then because amount of copper ion in the solution, that's right, as the amount of copper ion in the electrolyte will decrease, so one of the copper atom will go inside the solution as a copper ion, and the mass of the copper, the mass of the anode will start to decrease because the number of the copper atoms are turning into copper ion. So here anode, so the mass of anode will decrease. And why it is of 4 marks? Basically, the distribution is the mass of cathode is increasing. So why mass of cathode is increasing? Because the copper ions, one is for mentioning what happened to mass of anode and cathode, and next is the reason. Because the copper ions from electrolyte turn to copper atom. And why mass of anode decreased? Because the copper atoms changes to copper ion and move inside the electrolyte. Yeah, loss in the solution. That's also correct. Any term, loss in the solution, move into a solution, dissolve into a solution. These are the words, all are acceptable. Question 18 is basically identification of the ions. We have 2 solutions. One is solution J, another one is solution K. Test on solution J. So we have a solution J and we carried out a test on solution J first and then later solution K. Solution J was a colorless. Solution J was divided into 3 portions. A universal indicator paper was dipped and a universal indicator turned red. So what this gives an idea? This gives an idea it is acid. And what kind of acid is this? Because red color means that it is a strong acid. Then a spatula measure of a sodium carbonate. So whenever a carbonate is added to acid, acid plus carbonate gives salt, water, and carbon dioxide. So effervescence are there. The gas, which gas is this? This is the carbon dioxide, which turn a lime water milky. Then a nitric acid followed by silver nitrate. So this is a test for halidine. This is a test used to identify chloride, bromide, or iodide. If it is a chloride ion, it will be a white precipitate. Bromide ion, it will be a cream color precipitate, and iodide ion, it will be a yellow precipitate. So because it's a white precipitate, so this gives an idea it is chloride. So first it gives an idea it is acid, so it contains hydrogen ion, and later we identify it contain a chloride ion. So what is this acid? This acid contains hydrogen and chloride ion. So this acid is hydrochloric acid. So use the observation from test 1. Suggest the pH. Strong acids can have a pH 1 or 2. So you can write 1 or you can write 2 here. Normally for a strong acids, you can write 1 or 2, but 2 is also correct. Name the gas given off in test 2. So which gas is given off? So carbon dioxide gas is given off. But in exam, don't write the formula, like don't write CO2, because they ask the name of the gas, not the formula. So you have to write that the carbon dioxide is the gas which is given off. Then identify solution J. What is solution J? The solution J is hydrochloric acid. Then test on solution K. Solution K, they already mentioned it is the ammonium nitrate. So we know that it contains ammonium ion and it contains a nitrate ion. Complete the expected observation. Solution K was dissolved in water to produce solid K was dissolved in water to produce a solution K, and which is divided into two equal portions. First, we had nitric acid followed by barium nitrate. So what will happen, because basically this barium nitric acid followed by barium nitrate is a test for sulfate ion, but there is no sulfate or carbonate here, so it does not give a positive result. So we will mention there will be no visible change or there will be no reaction, because this is a test for sulfate, not for nitrate ions. So there is no change or no visible change or no reaction, you can also mention. Then 2 cm cube of sodium hydroxide was added to the second portion. The mixture was warmed and the gas is given, that gas given off was tested. So whenever we add sodium hydroxide and heat, that is a test for nitrate ion. That is a test for ammonium ion. Nitrate is with aluminum powder, sodium hydroxide and aluminum powder, and sodium hydroxide and heat, that is a test for ammonium ion. So when we test ammonium ion, what is the observation? A pungent gas, a gas with irritating smell, or like a strong smell, a pungent gas is given off, pungent gas is there. And what is the test for the gas? We'll test with a damp blue litmus, a damp red litmus. And when we test with a damp red litmus, it will turn blue because the gas given off is a ammonia gas. So ammonia gas is released in both ways. When we test ammonium ion or a nitrate ion, both cases the ammonia gas is given off. The question 19 is also related to the alternative to practical test for identification of the salt. Two solids C and D were analyzed. Tests were done on each solid. Test on solid C. So first, a red flame. The flame color, you have to learn the flame color. Sodium is there, lithium is there, sodium is there, potassium, and for copper as well. Lithium is there, that is red in color. Sodium is there, yellow. Potassium is there, lilac. And copper is there, it is green and blue flame. So flame test is done. It is different elements, different metals have a different characteristic flame color. You don't have to learn all the metals, only for group 1 as well as copper. That's it. So test is done, so it gives an idea it is a lithium ion. Then a solid C was dissolved. 5 cm cube of sodium hydroxide is added, no change. So it means it does not contain any group 1. Group 1 does not form a precipitate with sodium hydroxide. So that's why. A piece of aluminum foil. This is a test. Now a piece of aluminum foil is added to a mixture in test 2. So whenever aluminum foil and sodium hydroxide, this is a test for nitrate ion. So effervescence, a gas is given off and a damp red litmus turned blue. So this also give off ammonia gas. So name the gas that turned the damp red litmus blue, that is ammonia. And identify solid C. So you can mention it contain a lithium ion and it contain a nitrate ion, or directly you can mention a name of the compound. It is lithium nitrate. So this test is nitrate conformation and the flame test for lithium conformation. Test on solid D, which is aluminum sulfate. So we know the ions which are present here. It contains an aluminum ion and it contains a sulfate ion. Solid D was dissolved in water to form a solution D, which is divided into 4 portions. When we add sodium hydroxide was added and then in excess. So first, when we add sodium hydroxide, the aluminum salts will give a white PPT because of aluminum hydroxide, and then in excess, what we'll observe the precipitate dissolved to form a colorless solution. So first thing is mentioning the white PPT, and then the PPT dissolves to form colorless solution. Then when we add aqueous ammonia, the observation is white precipitate will be there, but in excess of aqueous ammonia, the precipitate does not dissolve. So the first one with sodium hydroxide, there will be a white PPT. So you have to mention first white PPT because few drops are added, and then excess, no change. The precipitate does not dissolve. Then about 1 cm cube of a nitric acid followed by silver nitrate. This is a test for halide ions such as chloride, bromide, or iodide. But because this solution does not contain a halide, so there will be no change, no visible change or no reaction occur. Then a nitric acid followed by barium nitrate. This is a test for sulfate ion. And whenever sulfate ion, it will give a white PPT of barium sulfate. So there will be a white precipitate due to the formation of a compound known as barium sulfate. You don't have to write the name of the compound, you just have to mention the observation because we are completing the observation. So this was the mock from chapter 5 to chapter 8.